Hi guys, so welcome. This is me again, Lawrence. For this today's video, this will be a review of your first quiz. So, kudos dun sa mga naka-perfect. So, 100%. So, congrats. So, okay. So, question number one. So, first question ko is computation, right? So here it says a block has a mass, lies on a fixed plane, angle 2.6 radians. Okay, so ang solution dito, alright, so the solution here says that there is an inclined plane. Okay, and the angle is 2.6 radian, right? So, sa calculator nyo, set na agad kayo ng rad. Okay? Kasi by default, naka-degrees yan. So, iset nyo agad yan sa rad. Okay? So, I don't know kung ano nakalagay na mass kasi naka-random itong question. Kung napapansin nyo, iba-iba ang given sa bawat problem, bawat student. So, I'm not quite sure kung ano yan. But still, the solution to this one, okay. So, let's say this is the map. This is the block. Okay? So, obviously, the weight is always going here. And we have a normal force, which is like this. And obviously, the movement of the block is going down. So that's basically F is MA. So, when F is not equal to MA, then it means that it is stationary. But since looking at the diagram here, the block will obviously move. Right? So, there's only a very strict formula here. If you're going to remember this one, so it's gonna be the force minus frictional force is equals to MA. Now, the frictional force here is simply the coefficient of friction divided by the normal, multiplied by the normal force. Right? And always remember that the normal force is simply equivalent to the mass times g. But since this is an inclined plane, we're going to multiply it by the cosine angle theta. Alright, so that's the normal force. Right? So since on the other hand, our force here, the force that's going down is slanting, you're going to use sine. So mg sine theta minus coefficient of friction mg cosine theta is equals to MA. Now, all of both sides have mass, so cancel. So it's gonna be G sine theta minus mu cosine theta is equals to A. So this is your working formula for this kind of problem. Always remember that. So always remember that the frictional force is the component of the frictional force is mu mg cosine theta, and that's the normal force. Okay, so yun lang ang formula. So the Newton's second law of motion is behind the use of seatbelts, and that's basically the first Newton's law. So that's inertia. So yun ang reason kung bakit may seatbelt. So again, this is another problem solving. So constant force. Alright, so kanina is naka-incline, ito hindi naka-incline. So there is a table. Okay, so there's a table and we have a block. And you are using a string to pull it at this direction. So it says here that the constant horizontal force is 7.9 newtons and the mass of the object is 3.6 kilogram, and it has a frictional force of 2.2. So the frictional force is parallel or anti-parallel to the force applied. The force applied. So this is the force applied. So the frictional force is 2.2 newtons. So again, so assume that everything that goes right is positive. So F minus Fr is equals to ma. Right? And remember that this formula is from Newton's second law of motion, F is equals to ma. So whenever there's a force and there is an object with a mass, it will move dependent. So in every force, there is an interaction between mass and acceleration. Yun ang ibig sabihin ng Newton's second law. Alright, so force is 7.9 minus 2.2 and the mass of the object is 3.6 multiplied by the acceleration. So A is equals to 7.9 7.9 minus 2.2 over 3.6. So that's the answer. So that's the formula. So a moving object that has experienced zero acceleration means stop working, stop moving. Okay, so is this true or not true? All right. So for example, this is your road and this is your and this is you walking. All right. So this is you walking, and you're going this way. So it means here, it says here that your acceleration is 0. Alright. So remember that velocity is the change in displacement and change in time, right? And also remember that acceleration is the change in velocity and change in time. So it says here that an object that has experienced zero acceleration means stop working. Okay, so zero acceleration. So A dt is equals to dv. Integrate both sides. Time dv. So so it says here that if you have a zero acceleration, so basically 0 is equals to uh, v 1 2 v2 minus v1. So if acceleration is 0, then basically you are constantly your movement is basically the same. So what this means really is if your initial velocity is 1 and your final velocity is 2, then you did not move. So going back to the question, a moving object that has 0 acceleration means you stop moving. So this is not true because it doesn't really mean that you have 0 acceleration means you stop moving. It doesn't really mean that. For example, if you're riding a motorcycle, okay. So kapag piniga niyo yung silinyador, example, ang pagpiga niyo sa silinyador hindi naman gumagalaw-galaw, 'di ba? Kapag hindi niyo naman pinabago yung pagpiga niyo sa silinyador, 'di ba? Dire-diretso lang naman ang bilis niyo. Pero pag piniga niyo, ganoon. Pag binagalan niyo piga, bababa. So yun ang reason yan behind. But mathematically speaking, ito yon. Mathematically speaking, ito yung explanation. Yan. Alright. So I hope that's clear. So all objects moving at uniform speed are not accelerating. So parang ito lang din yung question kanina, no? So all objects moving at uniform speed are not accelerating, which this is true. Okay? Uniform speed eh. Hindi nagbabago yung iyong movement. So basically, in terms of formula, acceleration is v2 minus v1, and that's simply here. Okay? For example, initially, ang movement mo is 2, and then now 3. Therefore, your acceleration is 1. So, ibig sabihin, nag-accelerate ka kasi bumilis ka. Yun lang naman ibig sabihin nun. Alright. So, friction is like normal force, is a contact force, but normal force is perpendicular surface and friction is parallel. Actually, anti-parallel nga eh. So, next question. You are inside an elevator while standing in a weighing scale. Is the reading of the scale the same if the elevator is moving upward at a constant velocity and the elevator at rest? Well, there will be two scenarios now. First one is that the elevator is in constant velocity. If you said constant velocity, then gravity so it means that the acceleration is zero. Alright? So if you are basically on a here, weighing scale here, so if you are stationary, then you're not moving. So A is equals to 0. So basically the same. So picture represents which Newton's law of motion. So this one is second law of motion because you're going to exert a force in a particular mass and you're going to have an acceleration. Okay, so F is equals to ma. So Newton's law, this is third law because obviously, this is your jet, this is your Falcon. So you will exert the force of going here in order for you to go up. Okay? Third law of motion. And then the amount of matter, okay, the amount of matter in an object. All right. For example, this is your matter, and these are your atoms. Okay. So the amount of matter in an object is the weight of an object. Remember, guys, weight is equivalent to force, and that force is mg. This is mass. Okay, mass is the amount of matter. So this is false. Okay, so I hope that's clear. This is for the video. Please tune in for the next one. Bye bye.